So my name is. So yeah, my name is Aaron. I work at Tinder. I work with that guy too. And then today I'm gonna talk about memory leak on Android. So how many of you have all the memory error before? Oh yeah, almost everyone, right? So if you look at the crash reports, it will say java.land all the memory error, and then fail to allocate some bytes of memory, right? And what's worse is that's it. That's the only stack trace you ever get, right? Most of the time, and then there would be a little text underneath saying like, no, sorry, no stack trace available. So what caused this? So basically, this is like a heap memory. So and then the white space is like the available memory now, but you're allocating a much bigger object it cannot fit in. So that's why it caused the memory leak. That's why it caused all the memory. So some typical cause of other memory. The first one is probably just like you just use too much memory. Like we have view pager inside of view pager inside of view pager inside of view pager inside of view pager, right? So just use too much memory. So probably talk to your designer. Change some designs. Don't use less lightweighted stuff to present the view pager. Like don't use like fragments. Use like pure view. It has less memory footprint. Stuff like that, and then bitmaps. Bitmaps. It's huge, right? Our phone resolution is so high. Like for each pixel, it's allocated a lot, and it adds up. And we will be allocating a lot of memories. So considering like recycling the bitmap, so the system can reclaim those memories as soon as possible. And also maybe you can think about like downsampling the bitmap. Maybe you don't need like those really high quality images to show up in some of the screens, right? Like there's like bitmap factory options to say that you probably don't want to use like ARGB AAA, so that can reduce some memories when loading images. And then you might just use some libraries that are designed for pure Java server side, which has like literally like unlimited memories, but not for Android. One really good example is like JavaTime. Everyone loves it to use that to deal with like datetime APIs. But JavaTime on Android, it takes so much memory. So there is a guy called Dan Lu. He wrote a version of Android JavaTime which which ship with a version of JavaTime without time zone, and then it will load the time zone database as needed. Or so today's topic is about memory leaks. So there's also another reason causing all the memory, because you are holding some memories that it just leaks the memory, so you don't have enough space for new object allocation. So that's the main topic I'm gonna talk about today, is memory leak. So just like this cat, just never let those plastic bags won't go away. So but wait a second. Doesn't Java just have garbage collector? So you just don't have to worry about those memory allocation, memory dereferencing some stuff like that. So why are we even talk about like memory? Why is it even happening, right? But you just not as like this case. So if you have a reference always holding something, and then it's never gonna work for those garbage collection, because garbage collection starts from the root. A root in Android is gonna be an activity, and then when on destroy, if you're familiar with the activity lifecycle, when on destroy is called, so it means on the system it means the exact activity is ready to be garbage collected. But if you keep a static reference to that activity, it just or maybe a reference that outlives the the activity lifecycle. This garbage collection still saying, okay, that's a strong reference to the activity, so it won't get garbage collected. So it just will end up like this cat, and then that causes memory leaks. So how the memory leaks? So there's only one rule for memory leaks to happening, because that is just the reference to the root outlives the root's life cycle. Just like the activity I just give an example, and then if you have like static reference to a context or something like that. So it will, when activity is destroyed, it's supposed to be garbage collected, but it's not. And then probably you have some listeners, like location manager. You have listeners. If you don't, you should unregister those listeners when the activity is destroyed. So there's not like another listener. So it's the listener should not be listening until when the activity got destroyed, right? And then also be aware of anonymous class, because anonymous class has an implicit reference to the parent. So if you basically like combine with like listeners, often you have like create a anonymous class to implement that listener, and then because it has an implicit reference to the activity, and then after you go out of the screen and when activity is destroyed, it's still reference to that, and it's still reference to the host activity, so that would cause memory leak. So and also things like handle a post delay, and you post something after a few seconds, but your activity has already is already gone, but because that handler still holds that runnable still holds a reference to the activity, so that's getting never destroyed. To fix that, we can use like weak references, which basically means we don't increment the count of the strong reference to the object we are trying to reference, and then when garbage collect kicks in, and just it will become null. And then also there's memory leaking Android framework. Like authentication manager, I remember authentication manager in one version of the Android, it leaks memory. It just doesn't register the listening for account changes. And also there's, if you search memory leak on b.android.com, which is the bug track for the Android, there are so many of them. So, and also we have manufacturers like Samsung did pro jobs on those stuff. So today, also I'm gonna talk about a few tools to help detect those memory leaks. The first one is Eclipse memory analyzer. It's a very classic one. It's used by a lot of plain old just Java server-side people. And then I'm gonna talk about an automated way to detect memory leak called a Hecanary. And then in Android Studio we have it recently added the memory monitor, so you can just detect straight from your IDE. So let's first talk about the Eclipse memory analyzer. So there are a few steps to analyze the stuff. Basically, the first one, you have dump heap. So you can grab a heap from DDMS or Android Monitor, and then you have to convert it to another format, which because the Android virtual machine DAVIC, it's used a similar format, but it's not exactly the same. So you have to use the tool to convert over to readable by the memory analyzer, and then you can just analyze it. So it provide a language called object query language. It's very similar. The statement is very similar like SQLite and SQL statements. So you can select everything from one particular activity, and then where destroy is equals to true. So that means if you grab a few dumps after a few seconds, and then you still see they're existing, like using the query, you still see existing activities which supposed to be garbage collected, but it's not. So you can just do that. But that sounds really tedious, right? It's very manual work. So there's a guy from Square created this tool called Hecanary, which basically automates those process for you. So so the first tool is internally used, it's called Haha, which is headless Android heap analyzer. It's a really cool name. It's built on top of the fork of the non-GUI version of the Eclipse memory analyzer, and then because our tooling, the Android Studio is always improving, so the second version of the Haha, he just used the perflib from AOSP. Which is the the Android source code, and then yes, that's the Hecanary, and then it also supports some customization. If if you grab a heap dump and you wanna upload to a server or send a Slack message to you, it can be easily done just using the customization. So I'm gonna show a demo how to use the Hecanary. That's not. So in our dependency, I just add, the debug compile. Can you guys see this? No.
No way.
No way, right? Okay.
Hope this works for you. So go view presentation mode.
Yes. Yes. Yeah, that's much better, right? So basically, it's the dependency is called Hecanary. So debug compile. It's because what Hecanary actually does was when the Hecanary detects a memory leak, he will show a dialog, say, oh, there is a memory leak, and then it will give you a notification, and then you can view the stack trace on the fly. So, but you probably don't want to do that in your release build, right? You don't want to be, it's all in the production. You don't want to, get embarrassed. So if you do release compile with no op version of the Hecanary, it just does nothing. So let's go back.
Does it only work on Lollipop or better?
No, it works. I think most of, at least. Oh, that's just a trick for me to boost the build speed. Okay, it has nothing to do with the library. Okay, so this library, I think the mean sticky version was 14, so it should be, everyone should be on. And then, so if I go to, this much easier for me. If I go to the, so there's only one line actually to bring the to make the work. So you just call Hecanary dot install. And then so the structure of my activity is this is the entry launcher activity. Okay, sorry. I forgot about that. So this is the main activity, which does nothing, which basically there is a button and I launch another called a LeakActivity, and then I can go to LeakActivity. So why the leaks? So I'm using RxJava. So for every 100 milliseconds, I just output. I just mimic how the memory leak gonna work. So if you don't unsubscribe when activity got destroyed, this action will run forever, right? And then let's go back to the app. So this is, I think you guys didn't see this. So there's only one line of code to actually enable the Hecanary. Just call Hecanary.install. And then let's try to run the app to see how it works. Yes. So it's building. So you can see from so if I go to this LeakActivity, you can see the log. It's for every 100 milliseconds get a value, and then when it's destroyed, it still keep emitting them. So it's caused memory leak because we're not subscribing to it. So so that's the dialog you will see if there's a memory leak. It automatically this for you, and then it will give you a very nice notification. So say, hey, LeakActivity leaked how many bytes of the memory, and it goes to that. You will see the full stack trace of the stuff. So basically all those stuff means it's reference to the LeakActivity instance. So what is the LeakActivity $1 $0? So in Java, any anonymous class got named to $1 $0, something like that. So it's obviously it's the LeakActivity here, that's anonymous, but there is another tool who can prove that basically. So there is a command called JavaP, which will brings you the intermediates. So you can see the classes, and then so here you go. So here is the LeakActivity.1 and $.1. Can you guys see this? So you can see this is the declaration of the decompiled class. It says LeakActivity $1 implements args action1. Action 1, if you remember, it's just the subscriber, and then you see in the constructor it takes in the hosting activity, the hosting parent. Basically, it's the LeakActivity. So that's why it causes memory leaks. So let's just.
So wait, is this a stack? What is this? Sorry.
It's a decompiled Java class.
Yeah.
Yeah. So that's why I want to show you what is the LeakActivity number $1 means. Let's go back to the Android Studio. So to fix this, it's pretty simple. Just you have a subscription, and just make sure it's gone on destroy. You will unsubscribe from it. So what does this do? It just notifies the observer, or don't generate a sequence, don't generate the streams at all. So let's run the app to see if it truly works. So if I go to the LeakActivity, probably I want to go back to see the log. Okay, anyway. Okay. So it's generating the values, and then when you exit the app, it just stops. So when it goes back again, it keeps generating the value, and then because you unsubscribe it just stops generating, and then we will never get those kind of notifications. So this is generally how the Hecanary works. Yeah. Let's go back to the slides.
How did you get this log?
Because you mean the log here? It's called PICAT. Yeah, PIDCAT, PICAT.
Of course, Jake working for it.
Yeah, of course. So let's go back to the slides. No. So then I want to talk about the memory monitor in the Android Studio, because that's the IDE we are using every day, right? So if you bring up the Android monitor, and then if you bring up the memory monitor, you will see this very nice you will see this dialog, and then here it will tell you the memory usage. So if you have a really complicated app, you can see the memory usage increase, decrease, and then there's some GC event or something like that. And then there are the three very important buttons you can help to detect your memory leaks. So first one is called initial GC, which basically it's basically just like calling like system.gc. It will schedule a garbage collector in the future, very soon. And then the second one, you can dump a heap, which is the first step we're gonna do in the memory analyzer. And then the third one is allocation tracker, which you can track all the allocation you made in the app. Like you will see a lot of like strings and stuff like that. So let's also do the demo of using the Android memory monitor. So let's go back to this activity. Let's turn off the I forgot about that. So let's go back to the leak activity. And then I just don't call this. And then all I do just don't unsubscribe after the activity will destroy. As we can see from previous example, it will leak the memory, right? So let's run the app again. And here's the memory. Here's the monitors. So if you go to the, so if you go to the leak activity, and it goes back, and goes here, and it goes back. There's some 3 times, and then you initialize GC. Theoretically, if we are unaware of the event, it should be garbage collected, right? So we can grab a heap dump. So this is the second button, which grab a heap dump, and then you can. This is not readable by you guys. So there is a class list view. You can see a package tree view, and then go to your own package, and then you can see this leak activity actually still has 3 reference to the host activity. So you can say it has the it just referenced the leak activity. So you can know, okay, that's the that's where probably it's the point where you have memory leaks.
So the children on that right pane, the children were references to that object?
Let me. So yeah.
So then if you expand one of those, you're saying so that the children are referenced, those children nodes are references back to that?
Yeah.
Okay.
Back to the host activity. That's which now you have like.
So can you like select that line and do like a command down and then we jump to that source or no?
I haven't tried that though.
Yep.
Yeah. So. Yeah, you can just trace back. I think. I haven't really used the, yeah.
So out of the 3 variants, which one do you prefer?
I would prefer Hecanary because it's very easy to do and it's very lazy for me to do. And then and then we can exit the transition mode. And then we're gonna fix that, right? So we keep swipe, and then we run the app again. We go to the leak activity a few times. I think at one point, Android Studio has a kind of similar way to Hecanary. If we can straight from the IDE to see which activity is possible for leaking memory. So I schedule a system GC and dump a heap dump. And I schedule another one and dump it again. So let's see. So I can still go back to the. I'm still gonna, this is not my package. So this only has one. So there's no. So the leak activity $1 doesn't have any reference to the leak activity. So we solve the memory leak. So that's kind of a general idea. How are we gonna use the memory analyzer to do that? The real world case is much complicated than this. It's not. But yeah. So that's that. And then let's see. So the last slide is just give some a few references which help. The first one is general idea of how's the memory, how's the app memory on the Android, and then the second one was topic on how to manage the bitmap, and then the third one is a blog post about Java times memory issue on the Android. So you can think about maybe there's other Java libraries that not suitable for Android. You can just start think about those stuff, and then there's link for the Eclipse memory analyzer, and also there's a talk by the guy who created the Hecanary library, who is not Jake Warden. He gave us a talk on
Here.
how internally Hecanary works, and also there's a general guide on how to use Android Studio Memory Monitor. So thank you for having me here, and then here's my personal email. So if you have any question, you can shoot me an email. I'll hang around a little bit.